Recording.
Recording in progress.
Here we go. Oh, let's wait for Kate to sit down. We're having a speed warm up, so get ready for this. And when you finish, I want you to slam your pens. Well, not slam it down. Put it down so people obviously know that you're done. Not in too obnoxious of a way, though. Okay, you ready? Ready or not? Here we go. Sure. Middle of a speed warm up. We have one student finished long ago. The rest still working. That's okay. 3 finishers. All right. 4, 5, cool. 6. Half a finish. Okay. If you haven't finished, that's fine. Make sure you're able to finish. You still got, I'm not going to go over the answers, but check in with your neighbor, make sure that you got them right, and make sure that you did them efficiently.
Yeah. Oh, that's a 4. Okay. And then 3 for X. And then I got 4. That's a 1. Yeah.
Are we okay?
Yeah. Excellent.
So ultimately, I do want you to be able to do these quickly. Of course, if you just did x squared plus 9 and that's how you finish so early, then we might have a problem, right? Of course, each one of these results in what kind of a polynomial? Quadratic trinomial. And these are all perfect square, perfect square trinomials. This specifically is x squared plus 6x plus 9. It's that middle term that we're concerned with. And to get that middle term, you just take the first and second term and just double that at the product of the first two terms. So like number 4, that would be x squared plus 24x plus 144. All right, you made it. Do you like number 5? Do you like that one? Here we have we have x squared minus, are we good with that too? Then plus 1 over x squared. And then that number 6, I hope you like this one. I think we start with 49x squared minus 42xy plus 9y squared. So for all these, I hope that you are using your facts. We know what these are equal to. You don't have to use distributive property. Can you use distributive property? If you use it correctly, you could think about this as a plus b times a plus b. You could do that. It's just more work than I recommend doing. So this is where it's at. If you use this, hopefully it worked quite well for you in that. The only thing slowing you down was a matter of practice, which is fine. It's early in the year. We're going to be doing these a lot, so they pop up from time to time. Just make sure you're remembering the tool. Okay, today is day one of our last section, right? So we're here, quadratic equations. 2-day lesson. Let's do it. Definition of a quadratic equation. Well, you already know the word quadratic, don't you? Show me the main number for quadratic. What am I looking for when you hear the word quadratic? We're looking for 4? No, 2. We're looking for that 2, the power of 2. So, and of course, equation, the main ingredient for an equation is an equal sign. So just for completion's sake, an equation that can be written in the form salud de nada. Ax squared plus bx plus c equals 0. That is, of course, the equation in standard form. And a cannot be equal to 0. If a is equal to 0, what kind of an equation is it? It's a linear equation, which is a whole different ballgame and a lot easier to solve. Don't you agree? Well, let's see. Let's solve some quadratic equations. It says to solve by factoring. Are we okay factoring that first one? Factor out the 2x. Leaves us with 2x minus 1 equals 0. And I think we've talked about a property we could use here. Do you remember what it's called? The zero product property. Have you heard this? Otherwise known as ZPP. Oh, not zero product property. That's middle school. Here it's zero product principle for some reason. Okay, so it just means that 2x could be equal to 0 or 2x minus 1 equals 0. So x equals 0 or x equals 1/2. Easy. Comfortable? You've seen this before, I hope. The number one problem with B that student, not the problem with B, but number one issue that students have with B is they do something that is not allowed. Never divide by an unknown. Never, ever, ever divide by an unknown in this class. You'll be losing solutions. Instead, we'll set it equal to 0 so that we could use the zero product principle, otherwise known as ZPP. Are you down with ZPP? Hello, welcome. We have a photographer here. Okay, pretend like you care, like you're having fun. I'm just kidding. Okay, so we'll move that 9x, 3x squared minus 9x equals 0. I'll let you finish that. Jean, is it?
Yes.
Thank you for coming. Do you know anybody here?
I'll listen to us.
Oh, okay. The rest are great too. Make sure your neighbor got the same thing you did for B with words.
Thank you so much.
My pleasure. So of course we factor out 3x, x minus 3 equals 0. And we know that x equals either 0 or 3. Yeah. For C, what should I do first? What's that? Why would we want to set it equal to 0? So we could use, I just want 3 letters. So we could use ZPP. Exactly. We like that 0 for quadratics. Once you finish C and D. Found some happy young people to help me with C and D. Make sure you discuss with your neighbor. Did you get it? Did you get both of them? Okay, Jojo, could you help us out with C, please? Walk through, please.
Um, so you can factor it out into the quantity of x plus 4 times the quantity of 2x minus 1 equals 0. So x can equal -4 or 1/2.
Are we good with this? Is this step an essential skill for you to have, that factoring stuff? Absolutely. If you're not sure how she did that, if you have any question at all, put some big question marks there and then make a note to see me or someone to help you out with that because that's not going away. Jojo, thank you very much for your help with that one. From Jojo to Joanna. Did you already do D? Okay, can you help us out with this, please?
Oh, wait, I'm sorry, just factor it to x plus 1 quantity 2x minus 1. And then I got x equals -1 and 1/2.
Did she speak the truth? Nicely done. Thank you. By the way, in the context of this class, if we're factoring, if you say factored into, you don't have to say the whole quantity thing, though I appreciate it. Just say the x plus 1 times 2x minus 1. I'll know what you mean. I think I'll know what you mean. But I appreciate the attention to detail. The square root property. Do you like square roots? Do you like them? Do you hate them? Ambivalent? What's that? Okay, I can respect that. Square root property. If x squared equals some number, then x equals plus or minus the square root of a. Every number has 2 square roots, a positive one and a negative one. So doing this one, yeah, we see this is quadratic, but notice something's missing compared to the other ones that we've done. Yeah, what is that term called? Anyone remember? What is the term with just an X called? Would you just check in with your neighbor and see if they remember that vocabulary word? The term with just an X. Anyone? It is a linear term. If it's missing a linear term, it opens up a possibility that makes it easy to isolate that X. And of course, in this case, we're going to add 15 to both sides. 3x squared equals 15 divided by 3. X squared equals 5. We know that the solutions are x equals plus or minus square root of 5. Yeah. Okay, so I think we could do, let's do B also. So 9x squared equals negative 25. Ooh, I'll let you finish that one. Did your neighbor get it? How many solutions are there? Is there one solution? Two? None? Well, up until this chapter, there were no real solutions, but by the square root property, there are two solutions. It's plus or minus square root of negative 25 ninths. Isn't it? We're not going to leave it like that. We're going to rewrite that negative 25 ninths as, or the square root of negative 25 ninths as plus or minus what? 5/3 I. And we still have our two solutions. Nothing's changed. It's okay. Okay, for C, considering the warm-up we did, you might be tempted to expand at x plus 2. Would that be a problem to expand at x plus 2? It's not a problem for you to expand it, but instead we're going to do what to both sides as it is? We'll take the square root of both sides, right? It's already a perfect square there, so we want to cancel that square. We're left with x minus 2 equals plus or minus, I'll take away, plus or minus square root of 6. That is a 6. Nice. And when you have that radical in here, I'd like you to squeeze that. When you add 2 to both sides, squeeze it in on the left of the radical, please. So it's going to be x equals 2 plus or minus square root of 6. Just for formatting's sake. It's helpful later on, even this year. You'll see soon enough. So how many solutions did we have? 2. One of them is 2 plus square root of 6. The other one is 2 minus square root of 6. Yay. For D, the first step is to subtract that 11. X plus 5 squared equals negative 11. I'll let you finish. Check with the neighbor. I'm going to be calling on someone. You ready? Mackenzie, help us out, please.
So first you would do the square root both sides.
Okay. Okay.
And then you would subtract 5, so x equals negative 5 plus or minus, and then, well, I kind of like did it in one step, but then you would take out the square root of negative 1 to be just I.
Okay.
Plus I.
Are we good? Exactly what I'm looking for. Nicely done. Yeah, Katie?
How do we put that?
It does. It has to be on your face. Oh, that was bad. It has to be separate from the radical. So the only danger with how I wrote it is make sure that the I is not in the radical. So as long as you're clear, fine with either way. You didn't put in the radical, did you? I know you know better. Okay, cool. So completing the square. Do you remember completing the square from Algebra 1? Does this sound familiar? Does this process sound familiar? This is a great skill to have. And it comes from familiarity with expanding perfect squares. The way it starts is it gives you a partial expression, and then it says, I want you to finish that such that I can rewrite this as a perfect square. In other words, we're going to have to add a term. Would you check in with your neighbor to see what you're going to have to add? And I'm going to put a little underline there. Can you show me what we're adding? Show me what we're adding here. And it is a 9 that we're adding here because now this is x plus 3 squared. So what happened before is it wasn't a perfect square trinomial, but we made it a perfect square trinomial by adding that 9. Now, did that 9 just come from magic? Well, let's see. Not, of course, it didn't come from magic. It came from math. But here, just make sure your neighbor's okay with what we add here. And then, of course, since we're completing the square, we should be able to write it as a perfect square. Show me the number that we're adding. You might have to use two hands. You can make it happen. Yeah, all right. 25, not 7. 25, and this is now x plus 5 quantity squared. So what's the trick? How do we go from that 10 to the 25? How do we go from the 6 to the 9? Does that sound right? Is that what you were doing? That's exactly the process we're hoping for. The only thing when you're completing this square is that the leading coefficient to this process only works when the leading coefficient must be 1. I'm going to say this up at the top. Leading coefficient must be 1. And if it isn't, you got to manipulate a little bit. But let's try a couple more. X squared plus, I don't know, 7x, minus 7x, excuse me. What do we add there? Did you get it already? This one's a little bit harder, isn't it? But not really. The number that's going to go in the blank is, well, half of 7, which I know is 7 halves. And we're going to take that and square it. Does that make sense? 49 fourths, which I trust you to be able to do. So now when I write this out, it's going to be x. In this case, it's going to be minus, isn't it? X minus 7 halves. That number is always half of this, isn't it? Always half of that. 1 half, half. And the other number, the filling in the blank, is the squared of it. So if we had x squared plus bx plus blah, that is a b, not a 6. But the number we add is b halves squared. Can you say that? B halves? Yeah, I guess you can. And the parentheses is going to be x plus b over 2 squared. Yeah. Is it bringing back memories? Have you done this before? Who has seen this before? Like you remember seeing it before? So maybe half of you. If you haven't seen it, it's not too bad. I hope. Okay. Oh, look. 3 more examples. Let's change this first one to be one that you haven't done yet. X squared plus, oh, I don't know, 16. Let's do that one. 16x. I'll call on 3 people to do this. And for each one, please write it as a perfect square below. It should be the number that you're adding and then something squared. So it should look just like this, ultimately. You check with your neighbor? You ready to be called on? Mackenzie, Jojo, don't forget about Chloe behind you. Are we ready? Okay. Hey, Chloe, help me out. What do we add? What's that? Yeah, just a number. I'm sorry, what do we add first? Yeah, so that's the number I was looking for. And then inside the parentheses is, you said x plus 8. Are we good with that? Going backwards from what we did in the warm-up, I hope that's perfectly, like, it falls in line with what you already know. Thank you, Chloe. Elise, B, what do we add here? So did I write it correctly? Am I okay like that? So 25 tenths over there, and then in the parentheses? Is this correct? Yes, Jojo? Oh, maybe I wrote it wrong. 25 over, 20 over 4. Sometimes I hear things. What's that? Oh. 25 fourths? Is that right? Any questions about that? Nicely done. This one. May, what'd you get for this? What did you add here? Okay. Are we good with this? Thank you. So can I just ask how you did this? I'm gonna just check. I imagine what you did was first you wrote this as 0.6667. Is that what you did first? No? How did you do it? Divided by 2. You're able to do that in your head? Okay, thank you. All right. For those of you who love changing decimals, let go of all that. Stay in fraction land. Unless you have to change the decimal. And I do want you to be able to change the decimal, but not at your own expense. Maybe that was fantastic. Thank you, all three of you. That was great. Okay, so this one, let's do this 2 different ways. Let's use can we use ZPP here? Let's do ZPP. I think this factors nicely. Are they 2 numbers that multiply to 5 and add to -6? Yeah, -5, -1. We see the answers are x equals 1 and 5. Okay, so we could do it by ZPP. Of course, if this were a question on a test and you did ZPP, that'd be great. I'd be very happy for you, but I couldn't give you full credit because it says very clearly to use completeness square, solve it by completeness square, which means I want that constant term on the other side. So x squared minus 6x. I'm going to leave a space there because I'm doing something called planning ahead. Completeness square, I need to add. Yeah, I'm going to add 9 to both sides. Does that make sense? Now, if you'd want to do some next level thinking, you could think, I want this to be a 9. Would that make sense as a desire if you're trying to use completeness square? In which case you just add 4 to both sides. If I'm going to say be a robot, if it's a constant, move it to the other side and complete the square like I've done here. The results are the same. How am I going to rewrite that left side? It's a perfect squared trinomial, so I can rewrite it as x minus 3 squared equals 4. And now take the square to both sides. So we have x minus 3 equals plus or minus 2. And when we move that 3, do you remember where I want it? I want it in front. I want a 3 plus or minus 2. Actually, this is where it comes in handy to let you know why. Because this is true that it's the same thing. But if you have 3 plus or minus 2, what I do is I imagine a number line and I think, okay, 3 is right over here. And then from this 3, I add 2 and subtract 2. Does that make sense? Can you visualize that? As opposed to starting with -2 and then adding 3 and then starting with +2 and adding 3. It's just you start with a fixed number, then add and subtract from that. So you can't, please don't leave your answer like that. I want you to do all the work for me. So 2 plus 3 is 5. 2 minus 3 is 1. There we go. Katie, it looked like you had a question. Oh, yeah. It would feel so incomplete if I didn't, wouldn't it? Try B. Let's see if you can replicate that experience. I will be calling on someone to help me from start to finish. Check in with your neighbor when you are done or stuck. We ready? 10 seconds. Okay, ready or not, I want to see what you got. Sam, can you help me with this one, please?
Where should I start?
At the very beginning.
Oh, 1/4. I to both sides.
Do you mind if I leave a space there where that one once was? Okay.
Now you're gonna add 4 to both sides.
Okay.
Square. So now you have x plus 2 squared equals 5.
Okay.
Which it's x plus 2 equals plus or minus root 5. And then subtract the 2. So you have x equals -2 plus or minus root 5.
Is there anything else we can do? Are we good with this? Any questions? Nicely done, Sam. Thank you. By the way, I mentioned it earlier. Could you just check in about terminology about that which I just circled? What's the best name for that expression right there? So what am I looking for? Quadratic? Quadratic. What is it? It's a quadratic trinomial for sure. It is a perfect square? Yeah, it's a perfect square trinomial is how I refer to it. Perfect square trinomial. Was there another way we could describe it? Yeah, very generally, it's a quadratic trinomial, but I would call it a perfect square trinomial. And that's why I could rewrite it as something squared. We created that perfect square trinomial. Incredible. Okay, this one. Shall I move that 4 over there? I could, but first I'm going to divide everything by 9 because that leading coefficient must be 1. So when we do that, we're left with 9, x squared minus 6/9 x. Maybe I'll move the 4 over there at the same time. What do you think? Maybe that 6/9, I'll just change it to, what's that? Did I do something wrong? 6/9 is the same thing as 2/3. See if you can finish this one. Yeah.
Have to divide by 9 first.
You can move the 4 over first. Eventually you have to divide by 9. Make sure your neighbor is okay with this. I will be calling one person to help us out.
Yeah, see,
I forgot that. Right. I should be. I should be all the
One.
Right. With what's in 20 or 50. It's like.
Because probably.
2, 5. We could simplify that to x.
It was just very nice.
Simplify that. One.
Are you all ready? Okay, Charlotte, I think Destiny loves you. Every time. You've been chosen. Can you help us with this one, please?
Like all the way through.
Yeah. Well, after what I've done. So, Mackenzie, I'm going to ask you to face the front for now. Thank you for being on it. How did you get the 1/9? Okay, so 1/9 here. Thank you for keeping it balanced.
X plus 1/3 there.
Is it plus 1/3? Okay,
That equals
love it. This is a positive square root? Okay, so square root of 5 on top and 3 on the bottom like that. Okay. Okay. Should we continue?
one plus.
Oh, 1 plus, so kind of to like this, like that. Nice. Yeah, I never need you to separate them, but thank you for acknowledging that they are two completely separate solutions. Very nicely done. This is acceptable too, but if you're comparing these two or these two, do you see that neither one is simpler than the other? We weren't able to do anything, put them together. So we could, which is great, but you could either let them separate or together, or just ultimately separating them completely as Charlotte did. Charlotte, that was fantastic. Thank you. Before I let you zone out for a little bit, Kara, every year I'm just blown away by the way students see things. Like I never would have seen this. Could you explain to us do you mind sharing with us what you did for this problem? She went about it a different way, which I think is really cool.
I saw 9 and 6, which 9 is 3 squared and 6 is 2 times 3. So I went with 3x minus 1 squared instead of x minus 1/3. So I put a 1 there, plus 1 instead of that. So I have,
Wait, before you continue, do you see where she's going with this?
I just thought like it would be easier because I kind of hate fractions.
Okay.
So like, let me just do that. I mean, it usually doesn't work, but it just happened to have lucky numbers.
Yeah.
So I took that as 3x minus 1 squared equals 5. So then I did 3x minus 1 equals root 5.
Is this a positive?
So minus root 5.
Right. It's difficult to remember.
Then I kind of skipped some steps there, but 3x
We can skip
yeah,
right to the end.
x equals 1 plus minus root 5 over 3.
Look at that.
It's kind of, it was easier
Yeah.
than like bringing in fractions and
Yeah. Yeah. That was really nice. What do you think? Right. She saw an opportunity and seized it. Right. If this would have been like a 7x, it wouldn't have been possible. But the fact that she was familiar enough with her perfect square trinomials to recognize, oh, that's just a bit of this. She was able to, a bit of, what's going on with my pencil here? My stylus is not happy. It's a bit of that square right there. She was able to just make it happen. I thought that's beautiful. Thank you for sharing that with us. Okay, so I'll give you a chance to digest, enjoy until 2:32. Then we'll finish the lesson. Have you already finished D? Go ahead and start this now if you haven't. This is the last problem before you start on the homework. Tricks on this one, except the plain square. Check with your neighbor if you haven't already.
Especially if you finish.
No.
Oh, I mean.
About 20 seconds. Destiny will call one lucky individual. Are we ready? Ready or not? Let's see what you got. Haley R. And say, I heard the 3x over 2 and then what? Oh, okay. Adding what? 9 over 16 on both sides, you said? Are we okay with that 9 over 16, folks? Could you explain where you got that, please? When you say you divide it by 1/2, I think what you mean is you took half of the 3/2. Okay, so that gives 3/4 and then 9/16. Okay. Nice. Okay. Keep on going. Okay. Two what? I think 2 plus 9/16 is just 2 and 9/16, isn't it? Oddly enough. Isn't that right? That's how mixed numbers work. Okay. Oh, so root 41 like this over 4. Okay. And is that the end? What do you think? Are we good? Same destination you got to? Oh, negative. I missed the negative. Sorry, Haley. Yeah. Nicely done. Thanks, Haley. Thank you, everybody. I hope it made sense today. You have a little bit of time to work on your assignment.